Look up on a clear night, and you are staring into a galaxy holding an estimated 100 billion stars. It is an expanse of cold, silent vacuum stretching backward in time for 5 billion years. But if we plummet through the atmosphere and hit the solid ground of Earth, that silence shatters. Here, the landscape is violently, physically alive. Today, we are going to capture that physical reality on paper. Grab 4 colored pens: brown, blue, red, and green. Step by step, we are going to draw a master field map of the Indian subcontinent. By the time we finish, this will be a working tool. You will have a framework to look at any mountain, river, or plain and instantly read the geological story written into the dirt. Step 1. Take your brown pen. We are starting with the bones of the Earth. This diagram shows Earth's internal structure, a solid crust on top, floating over a semi-fluid mantle, with a solid core of nickel and iron deep below. This sketch illustrates the rock cycle driven by that intense internal heat. Primary igneous rocks form from cooling magma, which weather down into sedimentary layers over time and eventually compress into metamorphic rock under extreme pressure. When massive plates of this crust crash into each other, the land has nowhere to go but up. Millions of years ago, the Indian plate smashed into the Eurasian plate, forcing the rock to buckle and skyrocket into the atmosphere. Look at these notes detailing fold mountains. The upward folds form anticlines, and the downward folds form synclines. On the top of your paper, use your brown pen to draw the Himalayas. Label them as young fold mountains. We map this rock layer first because tectonic activity builds the high ground. Every other force of nature we track from here must react to the shape of these mountains. Step 2. Switch to your blue pen to trace the path of water. It starts right here, high up in these rocky valleys. This diagram maps the upper course of a river. Because the mountain slope is steep, the water flows with high velocity and extreme erosive power. It acts like a saw, cutting deep V-shaped valleys and narrow gorges straight through the hard rock. As the water reaches the middle course, the slope flattens out. The river loses its kinetic energy, begins to meander side to side, and drops the heavy silt it carried down from the mountains. Here is a hand-drawn sketch of the Gango River system. Using your blue pen, trace the Ganga originating from the Gangotri Glacier on your map. Do not draw a straight line. Give it curves to represent how it meanders once it hits the plains. Finally, the river hits the lower course where it meets the sea, depositing the last of its silt into fan-shaped plains. Mark the Sundarban Delta on your coastline. Water acts as a relentless sculptor. These rivers literally dismantle the high tectonic peaks we drew in step 1, carrying the rock down piece by piece to build flat, fertile terrain. Step 3. Take your red pen. We need to map the invisible forces above the ground. These notes point out the troposphere, the lowest atmospheric layer, where all weather phenomena occur. Inside that layer, wind obeys a strict rule. It always moves from high-pressure zones to low-pressure zones. You can see this mapped out in this sketch of the Earth's pressure belts. But the Earth is spinning. This rotation creates the Coriolis effect, a pseudo-force that bends these winds, giving them a sweeping, curved trajectory across the globe. Take your red pen and draw thick arrows sweeping from the southwest, crashing into the Kerala coast. This represents the southwest monsoon, pulling massive amounts of moisture directly from the ocean. The atmosphere is the engine driving the entire system. Without the pressure gradients pulling these seasonal winds onto land, the mighty rivers we mapped in Step 2 would simply run dry. Step 4. Let's color code the terrain. Grab your green pen and outline the northern plains. Look at the notes here defining the soil. Bangar is older alluvium, while Kadar is fresh, flood-renewed soil. It is incredibly fertile, but highly prone to flooding. Now outline the Deccan Plateau in the south. This sketch of a volcanic plateau shows how it was formed by multiple slow eruptions of basalt rock. It is rich in minerals, but the hard bedrock means farming here depends almost entirely on monsoon rains. To the west, outline the Thar Desert. Because the Aravalli Hills block the rain-bearing winds we mapped earlier, this region is starved of moisture. This page on the Indian desert highlights the result of those arid conditions. Without water to bind the soil, wind takes over as the primary agent of deposition. piling sand into crescent-shaped Barchan dunes. Note these dunes on your map. Finally, shade in the coastal mountains. The Western Ghats act as a giant physical wall, catching the monsoon rains and creating lush, green forests on their windward slopes. The physical zone dictates human reality. These combinations of rock, wind, and water determine where communities farm, where they mine, and the daily trade-offs of how they survive. Step back and look at your paper. You have drawn a complete, interconnected web of brown, blue, red, and green. You can now look at this map and understand the mechanics behind it. You know why a tectonic peak behaves differently than a volcanic plateau, and how invisible atmospheric pressure feeds the rivers cutting through those valleys. If you followed the steps correctly, your 4 colored pens have perfectly traced the physical reality of the subcontinent. Take this map outside. Look closely at the local landscape around you. You have the tools to read the geological story of the Earth right under your feet.